Okay, hello guys. So today I will show you how to arrange data into one file because last time I have extract the uh, statistical performance for 28 GCM. So for example, here we have a data set that show that validation here, statistical performance for 28 GCM. This is 29 GCM actually, but this one is the same GCM. Can delete that one. So we have 28 GCM. That for example, for this GCM, I have statistical performance for each grid point. But each grid point have a different value for statistical performance. They have ME, MAE, MSE, IMSE for VE and 20 GCM. The same thing with the other GCM like CSM2. I have all the grid point, the value of each statistical performance. But in this case, sometimes we want to extract only certain statistical metrics. For example, I only want MAE, NRMSE, P bias, NSE, MD, CP, and KGE. So today I will show you how we can extract only this certain statistical metrics and put it into one file so that after that we can do easily analysis after that. So I show you the code. So this is the code. We want to combine the selected statistic in one file. So the statistic that we want to combine is let me show you. Down here is actually I will put it up there, another file. So this is what we want to analyze. We want to only take MAE, NRMSE, P bias, RSR, NSE, MD, CP, coefficient of persistence, R2, and KGE. So for MAE, the lower is the better. If you have MAE value here, for example, validation just now, MAE here, this MAE, the lower the value is, the better. If the higher is not good, the lower is the better. The lower is the better. The lower the value of MAE is the better performance of that GCM. That is the meaning of this one. The lower is better for NRMEs, NRMSE. For P bias also the same. The lower the better. RSR also the lower is better. But and then for NSE, MD, CP, R square, and KGE, the higher is better. So the higher value R square is better. The closer it to one, number one, for something like that. So now we want to set our working directory where we put our data set, which is in this GCMPR extract here. This is our working directory. So we run this our working directory, set working directory, set WD, set working directory, run. And then we want to read our GCM list. Read our GCM list for station. So I have GCM list. This is my GCM list. So this is the name of 28 GCM that I used just now. Because I want to put this why I read this data set, because I want later on when we combine all the data set, I want to combine this GCM name, the name of GCM as the first column. Uh, that is only the purpose for this data set, so that I can easily give the name for the first column. Otherwise, it's 1, 2, 3, 4, 5, 6. And it's hard to understand which GCM is it. So GCM list is just to give the name for the column for the GCM, and then we read all the data of the validation for each of the GCM. We have 28 GCM just now, right? So each of the GCM we have many results for MAE, P bias, and everything. So we read all this GCM, set working days, run the station, and then we read this 28 GCM. You can run everything, just check that everything is correct. So nothing is wrong there. And now we want to combine MAE, because in my analysis, I want only MAE. I want to compare the performance of different GCM based on the MAE, mean absolute error. So based on this mean absolute error, I can use rbind, MAE, combine for MAE, rbind for that 2. So I read it means row number 2. This is row number 1 because I put this is row number 1, this is row number 2. So I will only read row number 2. Row number 2, so from 2 to 178. So row number 2 from V1 until V28 for all grid point for MAE. MAE only. I will extract only MAE for this GCM, for that GCM. And then for the second GCM, I will do the same. Third GCM, I will also do the same until 28 GCM. So for all of the GCM, I will only extract column row number 2. After I run row number 2, for example, I will take only MAE first, and then I will combine it with the column name just now. We are using GCM list. Column name station number 2. So this is the column number 2. Combine it. So it will. So MAE here, you can see, you can view the data if you want to see MAE. MAE, it's look like this, V1 until V178. So we have 28. Actually, this is 28. You see number here? Row 28 data set. But the row name is 1, 2, 21, 22, 23. We don't want this one. This row name, we want to replace it with the GCM list naming system that we prepare just now. So we run this one and then we view it. And then we can see MAE2. So after that, you see, it gives you the station name, the GCM name here. So this is the result for MAE for this GCM, and all the GCM will give you extract only MAE into one file. So after that, you can go directly down here. You can write the result for MAE2. So I can do this for example, EX. MAE, I run it, and then you will get this result. Oh, where did I put this one? This working directory just now, GCM PR extract. This. So the result will be state. Okay, state. This one, MAEX. So this is our result. You see, you can just delete this first column. This is our GCM. All the 28 GCM that under our study, and then we can compare the performance of GCM for grid number 1, grid number 2 based on MAE. So this is the result for all MAE, mean absolute error. So we can see here, maybe we can run something like this, and see the lowest one is, I think this EC3 VEC, the lowest MAE. So this EC3 VEC is the best performance GCM when we compare with the observed chip rainfall data. This GCM EC3 VEC is the best when we use MAE as a matrix. The worst performance is INM CM48. So the best one for this grid number 1 is EC3. Okay, this is how we arrange all our GCM data so that we can make a better analysis. And then you can map this result and compare for each of the GCM. You can compare. There's a lot of data if you want to compare, but at first we can see the result here. What is the result for MAE? Okay, I think that's all for today. Thank you for watching.